Okay, so we've got two questions here. Both questions involve using the conditional probability rule. There are other ways you could have done this. You could have started with a Venn diagram. You could have started with a Carnot map and done some clever sort of manipulation to get all the values you needed. The most efficient way for this problem, or both these problems, is to go straight to the formulas. So I know it's a conditional probability question because the question has conditional probability in it. When you're reading the questions, you should be looking for these types of things as hints about how to approach the question. So we've got the probability of A given B. We've also been asked to find the probability of A and B. That's in my rule. That's what I need to find. I know that this is 0.1, and I know that the probability of B is 0.24. This is a rare occasion when you've been given more information than you actually need. That doesn't happen often in maths, but this is one of those cases. So let's do that a little bit clearer. The probability of A given B is 0.1. We don't know what the probability of A and B is. That's what I want to find. And we know that the probability of B is 0.24. So from here, if I want to solve this equation, I've got to undo a divide by 0.24. So I'm going to multiply both sides by 0.24. And you should be able to do that without a calculator. But if you can't, then break out your calculator to do that. That is a simple enough multiplication problem to be expected to do that on a technology-free test, for the record. But it is a multiple choice question, so it would be on a technology-allowed question. All right, second problem. Same idea. We have conditional probability in our question. We've got an AND in our question. We've got an A and a B in our question. We have to think about which ones we're going to use. So here though, notice my slight difference. I'm finding out the probability of B given A. It's really important that you change your rule around. The A and B part doesn't change, but what goes on the denominator does. Whatever my second term is what's on the denominator. Whatever my second term is the part that is on the denominator. Once I get to that space, it's then simple substitution. I want to find out the probability of B given A. I know that the probability of A and B is 1/9. Probability of A is 1/3. How do I divide fractions? Stay, change, flip. The first one stays, the second one flips, and the sign changes to multiply, which becomes 1/3. Which this one was the answer B. It is multiple choice, so we should always check that our answer's up there, and that one was A. Sweet. So this is where we left off last term. This is where we were up to. Is it ringing any bells? Little bit. All right. Remember, your test is on Wednesday this week. We've only got 2 lessons. It's coming up very quickly. You were reminded about that before the holidays. What we're going to do today is we're going to sort of like do a little bit more manipulation and playing around with conditional probability. And we're going to use conditional probability to discuss the law of total probability. So what we're learning about today is the law of total probability. The law of total probability usually comes up when we're using tree diagrams to represent a problem. So we're going to use some tree diagrams to find the law of total probability, okay? And then we're going to build up a bit of a formula that you may never use for the record. You may just work with tree diagrams. But before I start, what I want you to do now on your whiteboards, read this question carefully. And to save a bit of time, I'm going to tell you you're doing a tree diagram. Can you draw a tree diagram to represent this information? Go. Compare what you did to what I did. What do you notice? As I walked around the room, your tree diagrams, I didn't see anything that was wrong. Right? As I said, some people used percentages, some used decimals, some used fractions. Couldn't think there, forgot for a moment. Some people use symbols for love hearts to say they love maths. Some people used M and F. M was used for male. M was also then used again for maths. So we've got this overlap with the use of the variable M, where the variable M represented two different things, males and maths. Can become a little bit confusing. So, your turn to talk. What do you notice? What's the key difference that I did?
Use given signs.
Sorry?
Use given signs.
So I've used the given signs. So my first thing here, I haven't just said that they love maths. This path here was the chance that they loved maths given that they were a female. We can't actually just say this is the probability that they love maths because it's not the same in both of them. There was an additional condition that changed it. So I really should specify that this is the people who love maths given they're female. This is the people who love maths given that they're not female. What else did I do differently? Complement symbol. Some of you use that over here for maths and not maths, but I didn't see it too often at the beginning. All right. To move this along, because we lost time with computers not working, I set what the variables were. I've actually stated what each one represented. If you were doing an investigation, you wanted to maximise your score, this is part of your working out. It's saying these are what my variables are. Females, not females. Love maths, not love maths. The probability is on my branch. The outcome is at the end of the branch. I don't think anyone in this class had that back to front, which is good. Most of you had them the other way around, that's fine. Doesn't make a difference whether you put male or female first. But then I did my calculation. The only path that we were interested in was the path that they were female and loved mathematics. So in order to get there, we had to take the female path multiplied by the chance that they loved mathematics, given that they were female, times those two together, 0.0816. No, you're not expected to do that in your head, but you probably should be able to do it on paper without a calculator. If you can't, ask. I did change it to a percentage just because the question was written as a percentage. Key things though, how did I work out the probability? I just followed those two branches and I multiplied them together. If I got my notation wrong, as long as you can get the answer, you're probably still going to get full marks. Okay, well let's mix this up a little bit. Today, what we're going to talk about is how we find the total probability of something. So what if I just said to you, exactly the same conditions, except now, I don't want to know the probability of it being a female and loving maths. I just want to know what's the chance that they love maths. What will you need to do? Okay, I'm going to find the probability of a male student and loves maths, and then I'm going to find the probability of a female student and loves maths, and then I'm going to add them together because they are my two possibilities that give me the outcome that I've selected someone who loves maths. So they're male and love maths or female and love maths. And when I have that word or in probability, I add. Can you have a look at your tree diagrams and try and work that out if you haven't already? So in the interest of time, this is how I did the problem. Have a read. What do you notice? Everything that I said earlier, just I've used all of the mathematical notation. Do I need you to use this mathematical notation? If it was an investigation task being marked on a rubric and I wanted you to show me everything that you know, yes, that's part of it. There's marks for showing correct notation. If this is in a test and it's worth 1 mark, I don't care how you get the answer, as long as you get the answer correct. If it's in a test and it's worth 3 marks, if this was a 3-mark question, then having the correct set out of the problem would probably be one of those 3 marks. So having correct notation would probably be one of those 3 marks. All right, so let's consider what we're actually doing. If we want to consider the total chance that we select somebody who prefers maths, we need to consider both possibilities. We need to consider the possibility that they're female and love maths, which we already did. That is the one we did, wasn't it? I think so. That was the first example, wasn't it? Yep, I'm getting 1 nod. Was that the first example? 2 nods, 3 nods, right, 5 nods now. Good, that was the first part. We also need to consider that it was a male who loved maths. They are my 2 possibilities. As I said, we add these together because this is one way we can get someone who loves maths, or this could happen and we'd get someone who loved maths. When we have that or for our possibilities, so it's this possibility or this possibility, we add them together. If I do that in fancy notation, it looks like this. The probability that I randomly select someone who loves maths will be the probability of being female and loves maths, or the probability that it's male and loves maths. Work out those 2 probabilities separate, add them together, get your final answer. Does that make sense? Logically, intuitively, that's my possibility. What you have actually done is just called the law of total probability. 5, 4, 3, 2, 1. Get it from the person beside you. Okay, under that law, I want you to have a go at this example. You may want to do it on your whiteboard first. There are 2 questions down the bottom, Grace. This is your example you're going to add to your summary journal after you've got it correct. So if you want to put it straight into your summary journal, feel free. If you want to do it on your whiteboard first to check that you get it right, do that.